Hello, everybody. Okay, welcome to the last section of chapter 3.3 density. Okay, in this particular section here, we will investigate what is the reason behind floating and sinking. Okay, primarily density. Okay, I would say that in our context, okay, most obviously when we talk about floating and sinking, the most common reason that pop into our head is actually heavy or light. I am heavy because I sink. I am light because and therefore I float. Okay, but actually this explanation of light, heavy, float, sink is actually not, I would say not wrong, but it's just not accurate. Okay, because when we look at heavy or light, it doesn't really 100% guarantee light will float, heavy will sink. For example, heavy object, I can have a nail that is like heavy, it will sink, yes, but I can also have a big heavy object, for example, a boat, a ship made of metal, but it's heavy, but it still float on water. Okay, so when you talk about floating and sinking, when you look at uh heavy mass, okay, it's not a, well, I would say it's not a guaranteed 100%. Heavy will definitely float, light will heavy will definitely sink, or light will definitely float. It's not 100% factor. Okay, there are other factors that we have to look at before we conclude whether an object actually is floating or sinking. And that actually factor that we want to look at is actually what we call mass and volume. And together, these two factors, they actually give us what we known as density of an object. Okay, now density of the object is defined using the formula, the ratio of the mass per unit volume. So which means when we look at density, we are actually not just looking at volume, we are not just looking at mass. We're actually looking at the two of them combined, the ratio of them, okay, whether are they in the correct proportions, okay, and then we decide whether the object possessing certain density, is it really able to float? Not just because it's heavy, that's why I float. Not because it's big, therefore I float. But I would say it's a combination of mass, big size, heavy, and volume, big size. So floating, sinking, actually we look at the weight and we look at the volume of the object. And the SI unit for density, I will say with the SI unit of density, which we controlled by the mass, SI unit is kg. Volume, the SI unit will be meter per second. I'm sorry, my mistake. It's meter cube. So the combined unit will be, you will have density having an SI unit of kg per meter cube. Okay. Of course, sometimes I would say gram per cm cube is also accepted, but it's just that if you look at SI unit itself, okay, it's kg per meter cube. For example, I give you density of object 500. All right. How heavy or how light is 500? Density 500 kg per meter cube. Okay. For our context, okay, in general context, so I would say water. Water density is actually, okay, 1000 kg per meter cube. Okay, so if you look at density of wood, which is 500 kg per meter cube, you will find that regardless of, I would say, like, no matter what's the mass of the wood, okay, coupled with the volume of the wood, you'll find that actually the ratio of these two combinations will give rise to what we call density of wood. And if you look at these two factors together, you will be able to determine whether wood sink or wood float on water. Because density of wood, okay, is actually lesser or lighter or lesser than water. Okay, 500 kg per meter cube is definitely lighter than 1000. And as a result, wood will actually float. Okay, once you factor in the mass of the wood, the volume of the wood, what will we have in the end product? Density. Okay, so density is often used as a gauge of whether the object is able to float or sink in a certain liquid. Okay, and of course, to find density, you definitely need the formula, mass over volume, which is what we see on the top right-hand corner. And of course, volume, the basic, if it's a rectangular block, volume will be length, breadth, height. Okay, so from there, you have maybe this length, breadth, and height. Okay, and from there, you'll find the volume in SI unit, density, coupled with rearrangement of the formula, you'll be able to find the mass of the wood, which is 0.01 kg, which is 10 gram. Okay, it's quite light actually. Okay, but nonetheless, regardless of whether it's light or heavy, when we look at floating or sinking, we actually should look at both mass and volume, or what we call density. Now, same thing, this is what I mentioned, okay, since density of ice, okay, ice consists of, is water. So you take a look at ice, which is made from water, but as we all know, when we cool down, okay, the density of material will change. When you heat up, the density of material will change. So when it's water at freeze, okay, you'll find that ice density is 917, water is 1000. So definitely density of ice is lesser. So definitely this is what we call ice has a lower density than water. And when you have a lower density, the only observation that you will have when I put it inside that liquid is actually ice will float. For example, if I use ice again, 917 kg per meter cube. If I put into a turpentine liquid, okay, you'll find that turpentine liquid in liquid form is the density is 868 kg per meter cube. The density is definitely much lighter than ice. So when ice is dropped into turpentine, it will actually sink. Okay, so the bigger the density, if you are bigger than the liquid, you will definitely sink. You're lighter, you will float. Okay, because density factor in mass and volume already. Okay, so if you look at the math, it's easier if you do the calculation. You look at the mathematics behind, you look at the number, big or small. Okay, but when we want to explain density in terms of explanation, in terms of keywords, like I mentioned before, sometimes you need to make sure you craft the answer so that the teachers or the markers will actually understand what you mean. Okay, so the marker will actually know the students understand density. The concept of density actually involve mass and volume. So what I generally encourage students to write is write in terms of keywords so that understanding is actually easy, is like more, I would say it's more acceptable, is more, the interpretation by teachers is like more acceptable. So there's no ambiguity around it. For example, if you look at density, the formula for density, okay, is mass over volume. Okay, so when you look at volume, okay, that mass and volume. So when I want to explain density, I will actually not just talk about mass. I will also talk about unit. So in my explanation, I have to highlight the fact that what happened to the mass, what happened to the volume. So for example, this I would say maybe for the same unit of volume, so maybe it's 1 meter cube, I would say that the volume is constant, same unit of volume. Then I will comment on the mass. Okay, so I comment on the volume already, so I will comment on the mass. Mass of the object where it's larger, sorry, the mass of the object where it's larger or smaller than object B. I'll comment on the mass. Then after that, remember what you just did is you make a comparison, you make a statement on the mass, you make a statement on the volume. But just by making these two statements, you actually have not tell the marker you understand what is density. Because the marker will not know what are you going to do with mass and volume. So what you are going to tell the marker is that you have to tell the marker that you actually know what is density, which is mass per unit volume. And from there, this is what I always tell students that this is about telling the marker what you know about density, or sometimes we will actually rewrite the formula in terms of words form. Then from there, the marker will actually know, oh, these students actually know mass, know volume, and he actually know how mass and volume interact with each other, which is what we call mass per unit volume. And once you have these three factors inside, you have explained mass, volume, and the equation mass per unit volume, then you are actually safe to conclude whether object A is denser or less dense than the object. For example, in my explanation, if I'm talking about maybe a particular object, comparing two objects A and B, so A and B can be of the same volume, but because mass of A is actually larger than mass of B, okay, now, just by looking at mass or volume separately, it doesn't tell you sink or float. It doesn't guarantee. So, but what you need to tell marker is that, hey, I'm looking at beyond mass and volume. I'm actually looking at the interaction of these two, which whereby you write down to tell the marker to say that you know density is mass per unit volume. This statement actually tell us your mass and volume, you're actually interacting these two factors together. And from there, you can actually make logical conclusion to say that the object A, because it's larger mass, same unit of volume, object A is actually denser than B. And because of that, A will sink in B. Okay, so this is what we mean by explanations follows using keywords, and you'll find that each keywords actually explain each other clearly. It's trying to explain the answer, but each keyword is actually trying to explain each other to leading to a better or leading to a very clear understanding of your answer. Okay, so this is what we mean by using keywords in your explanations. Okay, so same thing when I talk about steel ships, the very beginning. Why steel ships? Why ships are able to float on water? Okay, even though it's heavier. Okay, partly because one of the reason is because ship itself is made up of not just metal, not just steel. It's made up of different material. Where the different material consists of different different density. So the composite of that materials, example, it could be partial steel, it could be some wood inside, it could be even air. It could have cabin of airs or containers of air being built inside the ships as flotations. And together, this is what we call a composite material. They will have a combined density that surprisingly is actually less than 1000 kg per meter cube, less than water. And because of that, okay, I am able to, the ship is able to float on water, okay, on the sea itself, because the average density of the ship is actually much, much lighter than water. Okay, so in short, okay, when we look at density, what we have just done is we look at density, the concept of density when we talk about sinking and floating. Okay, so density will is first thing we look at is whether it sinks or it floats. Okay, and we talk about sinking and floating. We actually targeted it at looking at density by looking at it in terms of density, in terms of mathematics, in terms of formula. Okay, which is density is equal to mass over volume. And similarly, we look at how other than calculations, look at the density bigger or smaller than the liquid, we also look at explaining sinking and floating using density via explanations. Okay, so I have explaining of density by looking at keywords. Okay, so it's important to actually know what the topic is about, not just knowing the concept, but actually applying it in different even genre, whereby I'm looking at it in calculation perspective, or I'm looking at it in terms of explanation, qualitative perspective. Okay, so explaining in terms of keywords without doing any calculations. Okay, so if you still have problem with density, okay, you feel free to actually press pause and go back like maybe 5 to 6 minutes ago to see what are the important things that you actually just missed. Okay, or if you have any comments or you have any questions that you want to ask, you can leave it in the comments bar below. Okay, then after that, I'll get back to you ASAP. Okay, and same thing. Okay, I will be uploading videos on the concepts of the next few topics. Okay, into my channel. If you want to get an update of all these videos and updates, okay, remember to subscribe to my channel and actually to turn on the notification bell so that you will be notified whenever I upload my channel. So in the meantime, okay, if you want, you can look at the we call the recommended channels. Okay, at the regular channels and videos that is popping up. Okay, in the next few segments. Okay, but feel free to go and click on it if they are relevant to you. Okay, if not, thank you and have a nice day, everybody. Thank you very much.